What is the limit as x approaches 0 of sine of x over the square root of x? If we plug in 0 for x into the expression, we would get a 0 over 0 indeterminate form, since sine of 0 equals 0 and the square root of 0 equals 0. Which means we could use L'Hopital's rule, but I want to find this limit without using L'Hopital's rule using a simple trick. Sine of x over the square root of x looks a little like sine of x over x, and we know that the limit as x approaches 0 of sine of x over x equals 1. This is the fundamental trigonometric limit. This result has a geometric proof, and I made a video on this a while back, so I'll link the video in the description if you want to see the proof. What I want to do is leverage this well-known limit to find the limit we have here. In order to get sine of x over x in the expression, we need to multiply both the numerator and denominator by the square root of x. So sine of x over the square root of x is equivalent to sine of x over the square root of x times the square root of x over the square root of x. And if we combine the expressions in the denominators, this becomes the limit as x approaches 0 of sine of x over x times the square root of x. As x approaches 0, sine of x over x approaches 1, as mentioned earlier, and the square root of x approaches 0. So this entire limit is equal to 1 times 0, which equals 0. So the limit as x approaches 0 of sine of x over the square root of x is equal to 0.